first thing I want to talk about is errors, something I happen to be a specialist at. One thing I'm really, really good at, I'm just an expert at, is making mistakes. It's my thing. And you are going to make tons of errors when you code. It's just natural. It's so complicated and hard that you're going to make typos, you're going to have logic errors, and you're going to have really big bad errors that you just can't figure out. The first kind of error is the most common error that I make, every couple lines of code. And that is just a simple, they call it compile time error, syntax error, however you want to word it. It's when you mistakenly, the first kind, compile time error, is where you write some code that just will not work. For example, that first line, system.ow, is just an ouch. You just forgot the T. And when you hit return and you try to run that code, it just won't work. It's a syntax error, usually very easily corrected. There are other errors that are much harder to correct. And those are the logic errors, the runtime errors, the errors that you make, but the computer doesn't catch it for you. It's actually a blessing that the computer tells you you messed up and something's wrong. Even though it's frustrating when that happens, it's actually helpful because you can fix it. It's the errors you don't notice that you think you did it right, and then look down the road, the errors just start cascading on themselves, and you have this broken thing and you can't figure out where you went wrong. There also is a massive error, a shut down the computer type error, and those are exceptions. The classic example is the divide by zero error. Since you can't divide by zero, it's pretty dramatic, and Java is a safe language and will stop the program from executing. Less safe language might actually shut down the whole machine if you divide by zero. So you got to be careful. Those errors can be classified as the compile time errors, the syntax errors, your program won't even run. The runtime errors or the logic error, that's when your program runs, but it doesn't do what you expected. You made some kind of mistake, but the program still works. Frustrating. The worst kind of error is that blue screen of death error. Those are the nasty ones, the really bad ones. Some people call those exceptions. Those are pretty bad. Yeah. Yeah. The classic, it wasn't me. These glitchy things are just kind of examples of, those classic glitches that you see. Those are classic examples of a runtime error. The program still executes, but it doesn't do what you want it to do. And they can be really frustrating to fix. I'm going to, syntax error is that code that's not understood by the compiler. I do want to just do a little bit of a demo of what those errors look like and laugh a little bit, because you've probably seen these errors before. So if I have a program like this, when I run it right now, it is absolutely perfect and it works. If I, for example, remove that semicolon, and common error, forget to type it. Notice how helpful Replit is. It puts this little red thing up here. It highlights this thing. If you go over and hover over it, it even tells you what you did wrong. Isn't that cool? It's like insert a semicolon. Oh, how helpful. And it will throw in that semicolon and it will fix it. Some errors, like this one right here, if I were to type in the wrong variable and run it, it takes a while for it to detect it. Look at, it didn't detect it here, but it detected it when it ran it. So it stopped it from running, and it tells you, it gives you a nice error message that, hey, this thing can't be found. This SOM numbers can't be found. So it's kind of cool that it gives you it gives you a good error message and helps you find that error. Notice that if I mess it up here, though, it's a logic error, but nothing bad happens except it's not the result I expected. And if I was running a program that would...
You're sharing the wrong screen.
Oh, thank you. I did it again. Yeah, and if that ever happens, I can't see the chat, And I see Ethan was trying to help me out. Sorry, I can't see the chat, so feel free to just barge in there. Thanks, David. Sorry about that. Let me go over that again. Look at this compiler here. And if I remove the semicolon, look at the way it gives me an error and it tells me what's wrong. It also gives me a red squiggly, and when I highlight, it tells me what to do, which is very helpful. And that just kind of comes in handy. Notice this logic error though. It doesn't tell me anything's wrong, but it's wrong. And if I was running a test program and it might say something like, your program does not pass the test. And you'd be like, it works, look, some number is 20. Those are the errors that drive you crazy and cause you to bang your head against the wall. And another person looking at it will see it right away and say, you forgot your E in sum. Even though you won't see it, you'll look right past it. So debugging and the type of errors, stressful situation, right? Back to the slide deck, I do have a homework assignment, another to-do to add to your list of to-dos. I have a project that, did I put it in Google Classroom yet? Let's see here. No, I didn't put it in Google Classroom. I will get it in Google Classroom. But we do have it's called 1.4 Practice and Debug. There are a number of problems you have to look at. It will run the same program. You'll see the pattern. And then you'll have to decide if there's an error. You have to decide what kind of error, and you'll have to decide what line the error is on. So you do have a little bit of an assignment to do. Here I'll this time share the right tab. I'll add that assignment. Oops, it's not a material. It's an assignment, and it's going to be kill the bug. And hopefully it comes up right away. If not, I might have to just do it later. Uh-oh. Sorry about that. And hopefully that's the right one. Boom. Again, my apologies. I should have had that posted already. All right. Now what I would call the fun part of the lesson. What we're going to talk about is shortcut operators. And shortcut operators are really cool because they allow you to be smarter and be lazier at the same time. You can use these smart lazy techniques to save yourself multiple keystrokes, and some patterns in computer science are so common that Java has some shortcuts. Okay, all C-based languages use these exact same shortcuts. So the shortcuts you're about to learn work in Python, C, C#, C++, Java, JavaScript. They work all over the place. So these are pretty cool shortcut operators. The first one is just really cool. You take a number. If you want to take a number and just add 1 to it, it's such a common operation that you can just go score plus plus semicolon. And it's the same thing as writing this big long score equals score plus 1. You can also do it for minus minus. These are just very common. By the way, the technical name for it, if you ever are really bored and want to impress people at a party, they're called post-increment operators. It actually works if you go plus plus score. It has a it behaves differently internally. That's called a pre-increment operator, but you don't have to worry about it. Use the post-increment operator because that behaves the way you expect it to behave. It's really, really easy to do. So just to show that in code, if I wanted to take some number, right now I have some number equaling some number plus 1. I could just go some number, if I type it right, some number plus plus, and then it's right. And then if I wanted to just split, if I wanted to display that number again, I could see that that number has increased by 1. So it's a really handy, really easy way to do things. Minus minus behaves the exact same way, only subtracting 1. It's a really, really handy, easy to use shortcut operator. Encourage you to start using it all the time in your coding. By the way, it's such a common thing in the C-based languages that the C programming language, which came first, was improved by C++. So C++ is 1 better than C. Get it? It's like a coding joke. So C++ is 1 better than C because it's object-oriented, which we'll start learning about in the next unit. On Friday, we're going to have our first discussion of object-oriented programming already. So C++, 1 better than C. Yeah, that's my, oops. I don't know why that, I don't know what that's all about. Oh, I see what happened. I wanted to get rid of the word bar, so I changed it to Culver's, but something happened to the, yeah, oops. Sorry about that. Yeah. I remember how appropriate that joke was. A C and C++ walked into a Culver's. C spilled root beer all over C++ shirt. Outraged, C++ shouted, "Good God, man, you have no class." Yeah, okay, sorry about that. I wanted to clean up the joke and then I removed the cleanup. But when I copied and pasted it, somehow the formatting got off. Yeah, it's really funny, but I know how to ruin a joke, don't I? Okay, you have a challenge. You are going to be asked to do a little project today as a to-do. It's going to take you, a whole 10 seconds to finish, but you are going to be asked to use the post increment plus and the post increment minus to get the right result. So you are going to have to write a little bit of code here. And then I also challenge you to use a times time and divide and modulus and see if those work as well. Is it just plus plus and minus minus, or do those other operators also work? I'll leave you to answer that later. I'm going to ask you to get to 3, the magic number, and 42, the answer to all the questions, the Hitchhiker's Guide to the Galaxy joke. The next thing I want to introduce you to is something called shortcut operators. These shortcut operators are also incredibly powerful and useful. You see them all the time in people's code, and they just save you tons of time because you often will take a score and you'll want to say score equals score plus 100, or score equals score minus 100, or score equals score times 100, or score equals score modulus 100. All of those things are common things that happen, and this plus equals is a way to cut out and save you a bunch of time. It's so common in coding to take a variable and increment or decrement it by a number. So we just use that special symbol, that plus equals. The main thing you are going to struggle with is remembering the order. So I have some tips for you so that you can remember the order. When you're typing it the first couple times, you're going to be, or for a while, you're going to be like, is it plus equals or equals plus, right? Remembering that order is really, really important. And to help you remember that order, I have some tips for you. The first one is PE. Get it? Plus equals. That's the order. So if you're like, what do I do when I want to do I go equals plus or plus equals? Think PE. It goes plus equals. Think of that gym class, right? PE, get it? Get it? Is that helping? Okay, maybe not. If that's not helping, just be selfish and think of me. Not me, but think of me. And me is multiply equals. Keep that order in mind. It goes multiply equals. So if you are stuck, do I go plus equals or equals plus? Think me. Like multiplies equals, the multiplication comes first, PE, the plus comes first. Hopefully you remember that your entire coding career, and every time you go times equals, you'll think of me. All right, there is going to be a challenge, a Replit 1.4, where I'm going to challenge you to get to pi. That Replit 1.4 asks, I get to pi already, and then I'm going to ask you just to change those shortcut operators around and stop, instead of using pi equals pi plus 300, change it so that you say pi plus equals PE, remember? 300. And pi, for example, on this one, you could go pi plus plus. Don't forget those semicolons at the end, and it's just a practice activity to see if you can get to those things. Then I have the ultimate challenge. This is the big one today. I'm going to ask you to be creative and write a program that uses each shortcut operator, a plus plus and a minus minus. So you have like 6 different things you have to use, and you're going to come up to a number. So whether it be your birth date, you come up with a number, a 4-digit number is my suggestion, or a 3-digit number is fine too. But you come up with some number, and then you write a program that dances around that, and you do that challenge. So you pick a cool creative, no, oops, my bad. Sorry, you pick a cool creative number. My bad. You start at 0, and then you use each of those shortcuts. I challenge you to be creative and not boring. So come up with some of those creative ones. Now, part of this challenge, I admit, is having you start from scratch. So you're going to, in order to make that challenge, I'm sharing a different tab, I hope now. Oops, no, I'm not. There I am. I'm going to go plus and make a brand new Java program that's called My Magic Number. You can call it whatever you want. I'm going to create the replit. And then what I'm going to beg you to do, share the roadie. Roads? No. Oh, sorry, it's Dan Rohde. Phew. No. Guess what? I have a little problem. I don't know why it's not having me share. I guess I have to do this with the link. So I'm going to make a slide about that because I thought you could just type in my name. So what I am going to ask you to do is share this project with me so that I can see it. So share it with me, and I can't wait to see your amazing project. My apologies about that. I thought it was easier than it is. So another item on the to-do, share a project with Mr. Rohde. And then you're just going to, come up with some number. And then you're just going to go through, oh, look at that syntax error. And you're just going to go through a process where you get to some kind of magic number in some kind of creative way. Oops. And you work your way to that magic number. Maybe it's your birthday or whatever. So that's what I challenge you to do. Feel free to add that to the to-do list, the magic number challenge. That's basically it for the lesson part, but I want to quickly talk about the quiz and then give you work time, and then I gave you plenty to do, and then give you some chance to work on these things and ask questions. On Thursday, you are going to take a 3-part quiz. Just so you know, tomorrow's lesson is a little on the short end. and I didn't want to add any more to it. So tomorrow you'll probably have a little bit of work time. I'll probably only talk for about a half hour tomorrow. Then you'll have time to get stuff done. And then on Thursday, I'm not going to teach a lesson. I'm just going to give you the opportunity to take a quiz. We're going to check in. I'm going to make sure everyone's quiz works, and I'm just going to give you time to work on it. Your quiz is a 3-part quiz: the literacy activity, multiple choice questions from the AP, and a practice FRQ. First, for the literacy activity, each class we teach, we are asked to have one literacy activity, ACT prep literacy activity embedded into our class. This even includes gym teachers. So some of you may have done some of this stuff in even PE class. By the way, that means plus equals. Remember to keep that order right. So I'm doing that on this first test because it's the easiest test. And so it's a multi-paragraph passage, and you're going to be asked to write a 1-paragraph response onto a rubric, and I'll grade it, and I'll meet that requirement that I do an ACT literacy activity prep. It's not that bad, but I do follow the rules these days. Then you're going to have 15 multiple choice questions that are provided by AP Classroom. So if you still haven't registered for AP Classroom, you are going to have a crisis on Thursday. You'll have 15 questions, and they are provided by the AP. So they are rigorous, and I will grade on a curve because you might not get them all right. They are a bit on the challenging end. I did provide you some sample questions just in case you haven't been able to figure out how to get to those. Last time I checked, only 2 people had gotten to them. I think David and Alexa got to them, but I don't think anyone else got to them. I provided you a handy link in order to just see what those practice problems look like and do kind of like a sample run, just so you can kind of get a feel for what that quiz is going to look like. Then you're going to have a free response questions. These are usually the most challenging part of the AP tests, and rightfully so. You are going to be required to turn in a picture of your handwritten code, just like we practices. You will lose points for style. You are not allowed to collaborate or use the internet to research answers or Discord. You are not allowed to have out or open a practice assessment that I'm about to give you to practice that you can work on mainly tomorrow, but I'm just providing it today. The answers from this practice or the slide decks from the class are not allowed. So you have to just work from your brain on these free response questions. But for the first semester, you are allowed to use Replit, which is a huge gift. In fact, later in the semester, I'll provide you the classes and some of the code so you don't have to retype them in, because I'm just concerned with the solutions, not with your typing skills and your ability to copy code quickly. So just be aware that when you do the free response question, you are welcome to run it through a Replit, just the way we made My Magic Number. You are allowed to hit that plus button and write the code to test it to see if you got it right, and it performs like you think it should. So that's kind of a cool perk. Here are the sample free response questions that are also in Google Classroom. So the outcome, notice one of them just has you write down what you think that program will do. Another one has you write a program, and then you have another write the output, and then you have a really hard one, this D one we're going to talk about a lot tomorrow. It has to do with different types of numbers and casting them in precision. So tomorrow we'll talk about D, but you have to write code that just provides the average. In this D, just for your own information, you do not have to write the boilerplate code. On the actual question, I was much more precise about what you need and what you don't need. But on this one, I just kind of gave sample problems. For the A, though, you do have to write the boilerplate code. So that's just kind of what's coming. Oh, I take that back. On D, it does say write all code, including boilerplate code. Sorry about that. You do have to write it all. My apologies. All right, you've got a ton of work to do. I guess I'm ending 20 minutes early. I thought it would take the whole time, but hey, there we go. You have a lot of work to do. I'm going to beg Connor to throw that into the to-do list on Discord as well. I am going to ask you to get that. If you haven't got done 1.3b, that's a priority as well. I'm going to stop recording and